Today we're going to start chapter 13, and chapter 13, especially 13.1 today, we're going to look at what they call the time value of money. And this is the section in the chapter that's going to be most likely things that you have encountered before. Often in an Algebra 2 class is where you see a lot of these things first show up. Some of them will even a little bit younger than that, but towards the end of it, there's going to be components too that you might not have seen or seen used this way before. This is the part, this is the earliest things that you would have seen. This is simple interest. So simple interest has a formula I equals PRT. If you write this I, P, R, and T down, we're going to see these letters come up again, many of them. They're used the same way every single time. I is your interest amount. P is the principal. Principal has to do with how much you either invest in something, right, like put the money in the savings account, or borrow from something, pull it out of an account somehow, like borrowing money for a car payment or for your school or something like that. R is the interest rate. It's really important to recognize that this says as a decimal because you have to take whatever the percentage is. So we'll just do an example to the side, like 7%, and turn it into the corresponding decimal, which is 0.07. You have to use it in decimal form or it will not give you the right value. And the time being in years is also really important. A lot of times you'll see, especially when you do loans for things, people like to tell you loan amounts in months. It's 18 months, or it's 36 months, or it's 60 months. You still have to turn it into that number of years in order to use these formulas appropriately. The future value for a simple interest, you'll see all these letters showing up again. The P and the R and the T tells you how much you actually owe back at the end of the loan or how much you now have at the end of the investment. So that's what A is, and actually define it later, but I'll just mention it here. So A is simply the amount that you have after it's all over with, or the amount you've paid after it's all over with. Okay, you've seen these before. This is not new, all right? You may not remember it, but you have seen them before. This shows up typically for the first time in like an Algebra 1 course. It's probably been a long time ago. Okay, so we're going to do a real quick example, and it's kind of a funny example. It was already in my notes, and I would have pulled it straight out of a resource. I'll tell you why it's funny as we read it, but as I solve the following interest-related problems. Paul is owed $530 by the IRS for overpayment of last year's taxes. The IRS will repay the amount at 4% simple interest. We've overpaid our taxes many times. You get a tax refund. The IRS does not give you interest. So that's what's funny about the question, is because that's not the way that it works. But if you owe them money that you haven't paid in a timely manner, they'll charge you interest for sure. So it's kind of a funny question. I'm not sure who created it or why I chose it at the point that I did, but we can still do the problem. It's not a problem for that. The first here asks us, find the amount of interest that the IRS owes Paul. So there's two questions, we're going to do two questions, and there's two formulas that we've seen so far. This one, and then these two that are the same formula, it's just distributed, okay? So when we're asked simply to find interest, the first one that has the I in it is the one that they're asking us to do. So interest, and it also tells us that we're working with simple interest here. That's important. We're going to encounter another kind of interest later. But for simple interest, it's the one that I've already given you the formula for. So this is I equals PRT. So I is what we're trying to find. Okay. P is the principal. It's the amount of money that we're either investing or that we're getting as a loan. So what is P in this particular problem? 530. Yeah, 530. R is our interest rate as a decimal. So the interest rate that they give you is 4%, but I need it as a decimal. What is 4% in decimal form?
0.04.
Right, 0.04. Okay, and as you'll remember, you just move the decimal 2 places to the left from a percent to turn it into a decimal. And then the time, right? What is the time in this particular problem?
A year.
It's a year, so we're going to use the number 1. Okay? So go ahead and grab calculator, multiply, really, 530 times 0.04.
Dr. Lucas,
Yep.
how come you would do 1 instead of 365?
Because the time is always calculated in years. So even though sometimes they could give you a monthly amount or like a number of months or a number of days or something like that, we'll always turn it into years. And so this one would be 1 year. So what is 530 times 0.04?
21.2.
Say 21 what?
0.2.
0.2. And this is a dollar amount, right? So we'll put our dollar sign with it and put a 0 at the end. It's 21 bucks, right? Now, a better question really would have been if Paul underpaid the IRS, right, by $530, and they charged him 4% interest. What would he have owed extra? That would be the $21. But regardless, 4% of the $530 for a year is 21 bucks. Let me mark you guys came in. All right. The second question asks for the total amount now that the IRS is going to pay Paul back. And so because we've calculated the interest already, if you'll take a look over here at these two formulas, the second formula actually has the interest amount written out, PRT, at the very end. And this should make sense. This is supposed to be the principal, that is the amount that you owed or you borrowed to begin with, right? Plus the interest, that's your total amount. So if you've already found interest, you might as well use the second one where you just add the two values together. If you haven't found it, namely if they didn't ask Part A and they just asked you Part B, you might choose to use the first formula. But they'll both give you the same answer. It doesn't make any difference. So on this one, we want our principal amount plus the PRT, and we recognize that PRT is equal to the interest from Part A. So we have our 530 plus the 2120, and the total amount would be what?
251.
So I think 500.
550.
551 and 20 cents, yeah. Cool. Does that make sense? One of the things, I'll just make an announcement about it now, although I'll probably mention it again later. There are going to be some problems where you're going to have to round things to the nearest cent because it's money we're dealing with, like it has to be rounded. So if you're off by a penny, that kind of stuff inside of my math lab, it will sometimes allow flexibility and it will count you right, even if it's off by a penny from what it wants it to be or something like that. Sometimes it counts you wrong because it wants you to be exact. If you're off by a penny, I'm going to fix it inside of your quizzes and your tests because that's ridiculous. I mean, we're not going to be off by a penny and count you wrong. But so just know that because of some of the rounding that we do in this chapter, especially this chapter, decimals kind of come into play in a way that's kind of a little bit different than the other chapters that we've done, and I will make adjustments for those. So don't freak out about stuff like that. All right.
Second,
Yes, sir.
how you said that PRT was equal to the 2120 from the first one, but you didn't have Part A.
So you can either calculate it, right? So you could use this formula, and you could put the 530 in here, the 530 in here, the 0.04, and the 1. You could do it straight from here. Or you could use this formula right here, where you put the 530 here, the 1 plus, and then 0.04, and the 1 right here. So you would just have to calculate it from the beginning instead of having already known the 2120. You'd have to be calculating at the same time. Yeah. Okay, so this is simple interest. There are things that are simple interest calculations. Typically, they are with things that you borrow money for that are smaller things. So if you imagine like appliances, people sometimes finance appliances. We'll talk about more of that in the next section, I think it is, maybe at the end of this one. Or stuff like that, where simple interest comes into play. A lot of times, however, when you're working with things that are big amounts, and not that 530 is a big amount compared to like the $2,000 refrigerator we're going to see in another lesson, but IRS debt is often substantial. Your car borrowing amount for a car or for a house are often substantial. They're not done with simple interest. What they're typically done with is something called compound interest, and this you have definitely seen before too. You would have seen it either in an Algebra 2 course or maybe a financial mathematics course if you've had that in high school. Compound interest is interest that compounds more often than one time. Simple interest compounds one time. So compound interest compounds maybe annually, semi-annually, monthly. It could be daily. We don't see that often, but sometimes your credit unions or your banks will do things at a daily rate. Monthly and semi-annually and annually are really the three most common. Quarterly is another one that sometimes comes up. So thinking about those, annually means one time a year, right? You hear people talk about an annual sale or an annual event. It means it happens once a year. Semi-annually, do you know what that means?
Like not every year, but every
That's what it,
years.
that's what it sort of feels like it is, but it isn't. Nope, it's a good guess. It's every 6 months. It means twice a year. So the place where you hear this sort of phrased most often is with sales in stores. They'll say like Dillard's or Macy's or JCPenney or whatever. They'll say we have a semi-annual sale. It means twice a year. So every 6 months, twice a year. Monthly, how many times a year would that be? Yep, 12. I don't have it written in here, but quarterly is another one we'll see occasionally. Quarterly would be what? Every 3 months or 4 times a year, right? 4 quarters in a dollar, 4 quarters in a football game, right? Things like that. So 4 times a year. So our future value when we have compound interest looks like this. What you might notice is that I didn't start out by giving you an interest formula, did I? Right, there's no formula that just says I equals. We jumped straight into A. And there's a really good reason for that. You can't calculate the interest separately here. You have to calculate the total amount, and then if you want the interest, you have to find it afterwards. So it kind of works backwards of the way simple interest works. Compound interest is one of those very interesting things. If you haven't thought about it a lot recently, what you want to remember is that compound interest is what makes you money in the long run. So you've probably heard people say something like start investing when you're really young because compound interest is in your favor, because you get interest on the interest. It's also the same thing that when you take out a loan for something that's really long, especially really long, like a house loan that's like 20 or 30 years, compound interest is what makes the cost of that house significantly more than the sticker price of that house. I remember the first time that we purchased a house, it was a $100,000 house. That's what it was. We were living in Kansas at the time. It's like 20 years ago. And when we got to the closing for that house and we had to sign all the papers, it actually showed, and we'll talk about this more later, the amortization of the loan. And it would tell you like what you would actually end up paying if you paid the entire loan off. That $100,000 house would have cost us, because of the interest rate at the time, because it was a 30-year note and all those kind of things, $271,000. I remember it because it was such like a, oh my goodness moment. $271,000 we would have paid for a $100,000 house, because that's how interest works. So the longer you spend paying things off, the higher the interest rates are, the more it ends up costing you over time. But also, the more you invest at a younger age and the longer you let it grow, the more it will grow over time without you putting all the money in. So compound interest kind of works both for you and against you, depending on whether you're loaning or where you're investing. So a couple of things to be aware of and to be careful of when you use the compound interest formula. I'd like for you to notice that the exponent NT out here, both the N and the T are in the exponent. Right, so if you have calculator like I'm looking at Becca's calculator here, like a TI-82, a TI-84, a TI-85 kind of calculator, whatever, TI-83s as well. If you put the parentheses around the exponent, it will understand that it wants it all in the exponent. The tendency somehow, though, sometimes is to forget that the exponent needs to all be combined together. So what you're going to see me do when we calculate things is actually calculate what the exponent should be before I put it into any kind of a device, so that I avoid the accidental oversight of letting your calculator think that part of that's an exponent and part of it's multiplied afterwards, because your calculator does understand order of operations and it will do things properly even if you're thinking of it and not entering it properly. So you have to be careful. The only thing that's new on this list, right, A, P, R, and T, these are all things that we've talked about, is this one N at the bottom. N is the number of compoundings per year. So if it's annually, N is 1. Semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. Daily, we go with 365. We don't have to worry about the leap year thing. That's just kind of the convention. We're going to do 365, that kind of stuff. Okay? So we have to pay attention to the N, and we have to recognize those pieces. Also, keep in mind still, right, time is in years. That's really important, and the rate's a decimal. Those are the two most common mistakes that students make, is forgetting one of those pieces or the issue with the exponents that I mentioned earlier. Those are the three things that can happen on these problems that can make things look funny. It's also good at the end of the problem to say, does that sound right? Right, I mean, like when you're taking a look at the car payment, you're buying a $5,000 car. If you end up paying $20,000 for the $5,000 car, you should stop and say, I want to double check and make sure everything's right, because that sounds like an awfully expensive car. That's a lot of interest on that $5,000 car, right? Pause and ask yourself if something makes sense. That will often help you to catch mistakes you might have made too. All right, so let's take a look at an example. I do apologize, this is super tiny inside of my chart, but it should be printed the same on your sheet if you've printed them out. So we have an example. We've got a principal. We're going to find the future value and the interest. Now, I know it doesn't actually have a formula for interest, but I'm going to show you how we find that afterwards, because there is a way to do so. So our future value is where we're going to start. This is A equals P times 1 plus R over N to the NT. So let's actually identify what each of these pieces are. What is the principal in this problem?
7,500.
7,500. So this likely could be a car value, right? Could, 7,500. But maybe not right now, because cars are very expensive right now. If you haven't been looking, you just don't. It's not the time to buy a car. All right, so the 1 plus, that part's automatic. We don't have to do anything but rewrite it. R, my interest rate. What is my interest rate in this problem? 3.5%, right? So what would that be as a decimal? All right, so it's 3.5%, or we can write it as 3.5%, but I need to turn it into decimal form.
Don't you divide by
You can divide by 100, or you can equivalently do what?
Just put it 2 times the left.
Yeah, move the decimal 2 times to the left, which is the same as dividing by 100. Oops. So it ends up moving it to there. So you have a decimal point and then 0.35. Okay, so good? What is N going to be in this problem?
Is it 2?
It is 2. How come?
Because it says semi.
Yeah, semi-annually, that's the one we talked about with the semi-annual sales. Semi-annually means 2 times a year, so N is 2. And then for our exponent, that same 2 is going to show up for N. And then we need the amount of time, 25 years. Don't pay a car loan in 25 years. That's not practical now. All of a sudden, now this is not a car loan problem, right? This is some investment you've made or something, I guess. I don't know. So this is the point where if I were you, I would recommend not putting 2 times 25 in your calculator. You can do 2 times 25. It's really easy. 2 times 25 is 50. So as I enter it in my calculator, I would enter it as 50. The other thing that you need to be careful of, depending on what kind of calculator you're using, is recognizing that all the stuff in the parentheses is raised to the 5th power 50, not the 7,500. So what you don't want to do is to do 7,500 times the value in the parentheses and then inadvertently sort of like hit enter, right? Get that calculation and then do the power, because that means that the 7,500 is also affected by the power, okay? So let's do it a little bit carefully, just depending on what devices you're using. If you want to be at the utmost careful, if you're working, especially if you're working with the calculator that you end up using, like this is again one of those places where you're not going to want to use the MyMathLab calculator. I would strongly encourage you to have a scientific calculator with you. So I'm going to calculate the part that's in parentheses first, okay? So I have 1 plus 0.035 over 2. So it's 7,500 still at the beginning. And I know for some of you, if you're using like mine, you can do it all inside there at the same time and it will be just fine, but we'll be a little bit cautious for now. 1.0175. Do not round anything until the end. If you're doing it piecewise like I'm doing right now, write as many decimals as your calculator shows. Because if you round, you're probably going to end up with a rounding error at the end. Are you okay, Bryant?
Yeah, I was trying to find out how to do the fraction.
Okay, I can show you. And then we're going to have most of us might have a caret button or something like that to have the power. Let's see if I can find it for you. Okay. So if we just type it in like this, it'll work.
Oh, okay.
You don't have to it just like that's fine.
Mhm.
And there's that same value that I was getting on the 1 point.
All right, thank you.
You bet. And then again, depending on what you're doing with your calculator, this is the next part. Order of operations says that we would do inside the parentheses first, exponent second, multiplication last. So this exponent part, so I've got that 1.0175 raised to the power of 50. And I've got a lot of decimals in my calculator at the moment. Whoops. So this is, good grief, 7,500. And then I've got 2.3807,88932. Okay, keep them all. Just be on the safe side, keep them all. And then you're multiplying that by 7,500. And you have 17,855. This is the point where we would round. It is a money answer, so 92 cents at the end, even though it says on my calculator 916. It's 92 cents, okay? This is the amount that we would have after 25 years in that investment, we would say, okay? So this is the total amount. To find the interest, we simply take the total amount and we subtract off the original that we invested, the 7,500. So if I subtract 7,500 from this, I have an interest amount of 10,355. And that is the time value of the money I left in the account and didn't touch. I didn't do anything, right? The money just did its thing, and it just sat there, and I just kept my hands off of it. And in the time that it sat there and I kept my hands off of it, I earned an extra $10,000 by being patient. That's really what it is, by being patient. So this is my interest amount. Any questions on that? Okay, we're going to change the question around a little bit. We're going to find something called present value. Present value is the same thing as principal. So if you want to identify that this is the P in principal, it's a different perspective, but it's the same location in the formula, okay? So finding present value is equivalent to asking, what do I have to put into the investment now to have that $17,000 in the future? So if I were looking at this problem and looking at the numbers and everything, if I were to ask you, what would I have to invest in the account, given all these same conditions, in order to have $17,855.92, and I didn't have the $7,500 given, I would be looking for that $7,500 amount, so I would know what to put in for later. Okay? So there are people who are gifted money at different points. So maybe you have somebody passed away and you're left with money. It has happened once for me that we had some money left to us. We spent it. But what we could have done, right, is we could have said, okay, well, I want to have X amount of dollars at some point in the future to do something with it. How much do I need to just not touch for right now? And then I would know $7,500 in this condition, right, put it in there, and I would just leave it untouched. So that's what we're going to be looking at in the next problem. We have $9,860 that we want to have later. Okay, that's our goal later on. And our values are 8%, and it's compounded quarterly, and it's for 10 years. So it's the same formula that we did before. It's simply that I don't know P this time, and I do know A. So we're going to identify and fill these pieces in. Same as we did before, it's just we don't know P and we do know A. Yes,
How do you know which formula to use?
the problem tells you. This says present value. Okay? And the reason we know it's compounded interest is because the problem says compounded. So there's always words within the problem that tell you what to do. This one says compounded, so I need the compounded formula. Over here, when we did our IRS question, it said simple, so we knew that it's the simple interest formula. The problem will tell you, you do not have to read between the lines. Okay, so just look for the phrasing in there, it will be there. So on this one, it tells us we've got the compound interest formula, this is the formula. And it tells us I'm looking for present value, which means I'm looking for P. That's the unknown. However, the 9860, that's my A. My interest rate this time, 8%. What is that as a decimal? 0.08. N. 4. How come?
Because it's quarterly.
Because it's quarterly. Compounded quarterly means 4 times a year, N is 4. I still have a 4 out here too then. And then what's my time? 10 years. Okay. So some context surrounding this might be something like, I want to have $9,860 when my child turns 16. They're 6 years old now. I've got 10 years to invest. How much do I have to dump in the account now and leave it sit there in order for them to have that money later on? Something like that, right? That's the context that would be surrounding a problem like that. All right, so we're going to calculate it. The interesting thing on this, as we calculate it, is we actually have to use a little bit of our equation information, and we will do a little bit of simplification along the way. So this is the 4 times 10, like I mentioned before. I would encourage you to go ahead and just multiply that in your head if it's a problem like this. If it's more complicated, you might want to use a calculator. Obviously, this one's 40. And then we're going to let our calculator find the 1 plus 0.08 divided by 4. So this one's actually a very friendly value. It's 1.02. And this is to the power of 40. So I'll raise it to the power of 40. Oops. So now I have 9860 on the left, and I have P on the right, and then I have 2.208. Again, I'm just going to write them all out that my calculator shows. 0.39664. If your calculator doesn't show quite that many decimals, it'll be okay. I've definitely overkilled writing them down. I don't need this many to keep my values exact. I'm just going to go with what I've got, so that's what mine says. How would I solve for P?
Divide each side by the 2.2.
You got it. So that's equation stuff from high school. So you're going to divide both sides by 2.208039664. So 9860 divided by our 2.2-ish number. It's going to be about half, right? You're dividing it by 2 something. So we're looking at something that's going to be about half of 9,000. So the calculator, again, this is money, so we need 2 decimals now, so we will round. Mine is 4,465. And then it says 0.499, so that's 50 cents. It's like the gas station, right? They always put that extra 9 on there. It's not really the number it says, right? It's like that. And that's your P. So we would have to invest right now $4,465.50 under these conditions in order to have that $9,860 later. Yep, Kelly. You don't have to, but I don't want to tell you like, oh, just put 4, because sometimes 4 might be enough, but sometimes you might need 6. So you need a bunch of them. Honestly, at least 6 is probably sufficient. And in some of your calculators, you actually have the ability to use like the exact expression too. Like that's actually what I just did. I didn't type it in again from what you had before. Yours, I don't think you'll have that capability, but you might. You'd have to explore it a little bit. So yeah.
I have a question.
Yes.
So how did you get the 4,000 if you divide it on both sides?
Because when you divide on the right, these cancel, right? So this is the only division I actually have to do in the calculator.
Okay.
So we're doing our 9,860 divided by, my decimal doesn't look very good, but the 2.20-ish number. The problem that happens, let me just give you an example on this one. If you had divided by 2.20, right, if you had rounded off to 2.20 and you'd been like, oh, that's pretty close, you would have ended up getting 4,481. 4,481 is definitely going to ring in at an incorrect answer in my math lab. That is not close enough for it to think that that's the same value. So if you cut your decimals short, you're likely to get something that's substantially off, or at least a little bit enough off that my math lab recognizes it and says it's wrong. And then you're left wondering, did I really do the problem wrong, or is there a rounding error? So I'd encourage you to keep your decimals long to keep the rounding errors at a minimum. Okay. The next thing that we're going to look at is something that you have seen advertised before, but not necessarily exactly with this language. Effective annual yield. You might not have heard that phrase before. The effective annual yield is the annual interest rate you receive or that you pay, taking compounding into account. While you may not have heard effective annual yield, you probably have heard APY. APY stands for annual percentage yield. It's the same thing. So you hear it typically with car loans. They'll talk about APR and APY. If you heard that before, they'll say 0.9% APR financing for up to 60 months. Right? Or they'll say it with an APY in there. So APY is really the amount of interest that you pay in a year, given the compound interest of the investment or the loan. Now you'll notice much of this equation looks similar, right? You see that 1 plus r over n to the n? That should look familiar. It's a portion of the compound interest formula. It just doesn't have the p at the beginning. And the reason it doesn't is because the p at the beginning doesn't affect it. And it doesn't have the t up in the exponent because the time doesn't affect it either. So those pieces are left off because they're not needed. So as we're working with this, the calculation is the same type of a calculation. You'll notice what happens at the end is that you see the -1 and the times 100. The -1 is because it removes the original invested amount, or the original invested value. And then the times 100 means it's turning it back into a percentage. So that's why those are showing up. So let me show you how it works with an example. Suppose the bank pays a nominal rate. Nominal rate, when you see that phrase, is the little r in our formula. Okay, the word nominal rate means the little r in our formula of 2% on your savings deposits, which would be an awful lot these days. Savings accounts are generally not that high these days. We're going to find the effective annual yield, all right, the formula from before, if the interest rate is compounded, and we're going to do the example for monthly. We could just as likely, be asked to do it for quarterly or semi-annually or something too. There's nothing special about monthly, it's just the example. So we have y equals 1 plus r over n to the n, just that part of it, minus 1 and times 100%. Okay, so we'll go piece by piece, just like we have been. What is the r in my problem?
2.
So it's 2%, but I need it as a decimal. Right, so I have 2%, so this is 0.02. So in my formula, remember that's one of the things that is really easy to mistake, putting that value incorrectly. N. What is n in my equation? Not 1. 12. Why is it 12, Cooper?
This is monthly.
Yep. N has to do with how it's being compounded. Okay? N is the number of times per year, and this is monthly. There's 12 months in a year. So we have 12.
So it says annual, but that doesn't mean anything.
We're calculating the annual. The R is an annual rate.
Okay.
Yes. So we're going to be calculating the annual yield given the nominal rate or the annual rate of 2%. The N again is 12, so it goes right here. Have minus 1, and then times 100. So again, I'm going to go piece by piece. Some of your calculators definitely don't need you to do that. That's fine. But I'm going to be just extra careful here. So I'm going to do the part in parentheses first. Remember, you're working from the inside out. So I'm going to find out what is 1 plus 0.02 divided by 12. And I'm going to be careful to write down lots of decimals. Okay? Don't want my rounding errors to happen. It's not helpful. So this is 1.001, and there's a bunch of sixes. So I'll go with what my calculator has. Man, it has 5 sixes and then a 7 at the end, which is clearly a rounded value. And then we have that raised to the power of 12 minus 1 times 100. So I'll raise that to the power of 12 now, that ugly long number. When I do, I get 1.02018. And again, I'll keep all of mine. 4356. And then we'll subtract the number 1. Obviously, subtracting the number 1 keeps everything the same. It just doesn't have the 1 at the beginning, right? So now I have 0.020184356. And then we're multiplying that by 100. So multiplying by 100 moves the decimal 2 to the right. So it's going to come here between the 2 and the 0. And it'll tell you in my math lab how many decimals that it wants you to use. I'm just going to write down a few of them right now. Just pay attention. If it says round to the nearest hundredth, that's 2. Round to the nearest thousandth, that's 3 decimals. Round to the nearest tenth, that's 1 decimal. And if you aren't sure what the phrase is telling you, just Google it, right, to make sure that you're giving the right number of decimals. I'm going to go with 3 decimals for the moment on this one because it doesn't actually indicate, but yours will. So this would be 2.018. Really important fact. The annual yield, right, this effective annual yield will always be slightly higher than the nominal rate. The nominal rate was 2. This is 2.018, just slightly higher. That will always happen. So if you're getting something substantially different, you definitely have an error. It's only going to be slightly different. Yes?
How do you say 100% of the calculator?
You just do times 100.
Oh,
The
that's
percent
right.
is you don't do percent. The percent is the units at the end.
Oh, so you just do
You do times 100. Exactly.
I was wondering why.
Yes. Yeah, you just do times 100. Yep.
Oh, never mind. I see where, when you took the 1 off, you guys just moved up into this.
Yep, I did. And of course, your calculator will do it too, but it will. It'll just remove the 1 at the beginning. It'll give you all the decimal expansion afterwards.
And we can just put this whole formula into our calculator, right?
Depending on your calculator, yes. So you want to be a little bit careful. I'd try it a couple of times just to make sure. As long as it's giving you the same answer, then yes, you can. Yes. Okay, there's one more type of compound interest, and this is called continuously compound interest. This is interest that compounds continuously, as the name would suggest, as opposed to monthly, annually, etc. We're going to see an example of this in a minute where you can see how it's used. But it does have a formula. You may have seen this before. This would be, again, something that happens in Algebra 2 in high school, if you've seen it. This is the future value for continuously compounded interest. The A, the P, the R, the T, they are all the same definitions as before. This is A equals P times E to the RT. And you might be saying, okay, but what is E? If you haven't seen it in a while, E is a number. It's about 2.718. E is a button in your calculator specifically. You're going to use that button. So E is an irrational number, much like the irrational number pi. Pi is about 3.14, but that's not exact, right? So we don't want to use 2.718. We want to use the E that's the more decimal rich, if you will. It's longer expansion of it that's in your calculator. Generally speaking, calculations on this are easier to work with in your calculator. This is why you are going to need a scientific one as well. If you just have a 4-function calculator, it won't work. If you're using your phone as you're doing your homework or whatever, if you turn your phone to the side, it'll turn into a scientific calculator. There'll be an E button. You can use it that way. You can't use your phone on the test, but you could on your homework, okay? So we're going to do an example. They're very simple to do, easier to do than compound interest, compounded a certain number of times a year. So we're going to find, did I do that right? I just typed. This just is not supposed to say that. It's in your notes and it's in my slides, but that's not what it's supposed to say. It's just number 5. I don't know why it says that. Ignore that part. Using the data from problem number 2, that's where we had the little table across the top. We're going to find future value instead of doing it for compounded semi-annually that it said over here. Right here it says semi-annually. We're going to do it for compounded continuously. So in particular, our formula has it has A, which we're going to be finding. P is what we're given. That's the 7,500. We're going to use that interest rate, R, and the time from the previous problem. So P, like I said, is 7,500. E is the number in your calculator. R is the interest rate from the problem. If you go back to that problem, it tells you it was 3.5%, which is 0.035. That was on that chart. And time, which they told you was 25 years. Are those pieces all okay? So again, I would encourage you to be a little bit careful with that exponent. I'm going to do it in my calculator. I'm not going to multiply that in my head. This exponent ends up being 0.875. That's what that exponent is. So in my calculator, I can definitely enter this all at once now because it's just multiplication with that exponent. So 7,500 e to the 0.875.
Where's the E bus in the calculator?
It's different on different calculators. We've got 2 of them on yours.
This is the green E.
It's right there.
Okay.
Right there. It's also over here. Oops. So you're going to do 7,500 at the second. This one. And then this location.
It doesn't matter which E.
No, this one just automatically puts the location for the exponent in it, so I can use it for the letters. That's not it. Nope. You would be using.
It's different.
No, it's right at the top. Like you're in green, use your green button. Anybody else not finding it on their calculator? Everybody's good? Definitely you need it, so. Okay, the value that mine is saying is 17,991. Again, it's dollar amount, so we'll do 2 decimals, and it's 56 cents. Compounded continuously is the most it can be compounded, right? Because continuous. It's going to be the largest value. If you compare this back to the answer that we got on problem number 2 over here, which was 17,855, it's going to be slightly higher, and it is, because it's 17,991 and 56 cents. Okay, last thing for today, inflation. Ooh, inflation. Boy, we're there right now, aren't we? Inflation. This is the increase in cost of living over time. That is the purchasing power of your money over time. CPI is called the Consumer Price Index, and it's published by the U.S. Bureau of Labor Statistics and reflects the prices of items purchased by large numbers of people. Continuously compounded interest formula can be used to find newer prices due to inflation. And there's a lot to write down. I'll let you go back to the video and write those pieces later. I apologize for that. Inflation is really real, and it's a really big deal right now. It's the reason that our food pantry at our church has had an uptake in numbers of people coming in, because the prices of food have gotten quite expensive at the grocery store. My eggs keep going up. That's a really good example. I used to be able to get eggs for under $1 a dozen. Right now, the cheapest I can find them, absolute cheapest, is at the Dollar Tree. But at a traditional grocery store, they're $2.70 a dozen. That's just an example of one item that I've noticed recently that I've been like stranglehold. Orange juice. I used to be able to get orange juice under $2 for a half gallon. It's now $3.55. It's the cheapest I can find. That's due to inflation. And there's lots of reasons for inflation. The printing of money, all the money that was sent out by the government recently, that's part of your inflation that just happened. You put more money into the system, all the value of the money has to go down. It's just the way it works. So let me do a real quick example with you. It's just like the one we just did. It's compound interest. A equals P, E to the RT. In 2010, a small car, this would be brand newish, kind of, would cost $18,500. That's the original price. Principal, P at the beginning. If there's an inflation rate in 2005 of 5% over that time frame, then our 0.05 for our rate would be there. And we need the time. What is the time lapse in these two different details? 10 years. So we'd have a 10 here. If I multiply these two together, 0.05 times 10, I actually get 0.5. And if I take my 18,500, e to the 0.5, I end up getting that the cost of that same type of car, a basic, new, small car, 10 years later is now 30,501, and we'll put the decimals on there too, 34. It's a 5% inflation rate over a 10-year period of time. And that's why the cost of your used cars are up right now as well, among other reasons. So. All right, so we are finished with section 13.1. You're welcome to do the homework inside of unit number 9 to start with that, and we will do 13.2 on Monday.